An application, a very common application of exponential functions is something called compound interest. This is not simple interest where your interest is only calculated on the original principal or the original amount borrowed or invested. Instead, it's interest that will earn interest on the interest. It compounds with itself. So we have a little bit more complicated equation here, or formula. A, that's going to stand for the future amount, or some people call it the accrued amount. The P is still our familiar principal, the original put in or borrowed, and then it's times this whole quantity, 1 plus R over N, all raised to this NT power. R is the familiar rate, which we'll express as a decimal, and then T is also going to be time, just like it has been before. Remember, you have to put it into years. The new thing here is this N, and it's the same in both places, and it represents the number of compounding periods per year. It might be compounded annually, so once per year. Compounded semi-annually, twice. Quarterly would be 4 times a year. If it said monthly, we'd use a 12 for our N, okay, and so on. Right, so here we've got an example. We've got $750 invested 7%, compounded semi-annually. We want to find the amount of money after 5 years. So we've got all the parts labeled here. The semi-annually tells me my N, the number of periods per year, is twice, 2 times. All right, so I plug that in. Now notice I write it on paper. You probably didn't put these little parentheses up here. But if I'm going to put that in my calculator, I'm going to show you how it has to be put in. In order for your calculator to understand what you want it to do, you have to put this exponent in the parentheses. Otherwise, it's going to be very strict on following an order of operations and do the exponent raised to the 2 and then take the answer times 5. So you either have to do that multiplication quick in your head or remember to put the exponent in parentheses there. And then you should get the $1,057, okay, and 95 cents. If I'd want to know how much interest that was in those 5 years, well, this is the future amount. 750 is the principal that we started with, so my interest is going to be the future accrued amount minus my original principal, 307.95. All right. More interesting question, how long is it going to take for that $750 to grow to $2,100 if we just leave it alone? Okay, so we'd set up the equation. A is the future amount, so 2,100 here, equals our 750 times that quantity of 1 plus 0.07 over 2, all raised to the 2t power. Now I'm going to solve this graphically now because I don't have any tools yet to solve it algebraically. So if I'm going to do it graphically, notice I put 2,100, the left side is my one equation, and then the other side, the right side, is my second equation. But again, remember that order of operations is important, so I put this exponent here, the whole 2x, in parentheses like that. And I know I've got it on the screen, but I'm going to just show you here. I put them in my calculator. I also adjusted my window. X stands for the number of years, so positive years make sense. And I just thought 20 seemed like a good place to go out to. And the y's, well, we know it's going to get to at least 2,100, so let's go a little beyond so we're not right at the top. There's our 2,100. Here comes our exponential function. It takes a little bit of time, and then all of a sudden it starts growing kind of rapidly. What we're looking for is this intersection point. So I go to my calculate menu, second trace, and I go down to number 5. It says, is this your first curve? Yes, hit enter. Okay, is this your second curve? Yes, hit enter. And now it wants me to guess, so I use my little arrows to move the cursor until I get really close to that intersection point. The thing I'm looking for, that's my guess. And I hit enter, and it gives me this result here. Okay, now what I'm getting here is the x and a y. Well, we knew what we were going for with our y value. What we're interested in is the x part. So it would take about 15 years for that to grow to $2,100.